Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Muhammad Sapian. So my title for my PSM to my title for my final year project is analyzing UDP flight attack detection in IoT using machine learning. So this research is basically to detect the UDP flight attack that occurs in IoT environment using machine learning. Okay, the problem statement of this uh, research is UDP flag attack is one of the attack that very easy to deploy in IoT network, and despite of this extensive past research in general, DDoS detection and prevention in industry is still lack effective tool to deal with this type of attack. So the question for this research is, what is the algorithm for detecting UDP flag attack in machine learning, and then how to apply the detection algorithm in dataset using machine learning tools, and lastly how to compare the accuracy result of the machine learning algorithm. The objective of this research is to study the algorithm for detecting UDP flag attack in machine learning, to apply different algorithm in detecting UDP flag attack dataset using machine learning, and lastly to make the comparison result of different machine learning algorithm. So for this project, I will be using Weka tools for my machine learning tools, and the dataset that I will use is DDoS CIC DDoS 2019 board IoT dataset and Edge IoT. And the machine learning algorithm that I will be used is SVM, neural network, logistic regression, naive Bayes, and random forest. The expected contribution of this research is to understanding the algorithm of detecting UDP flag attack in the IoT, and then propose the usage the different algorithm for getting the result, and lastly to propose the best algorithm for detecting UDP flag attack dataset after making comparison. So in general, the dataset need to done the pre-processing step to make sure to make the dataset ready for uh, classifying step. So in the processing step, we need to acquire all the file, the CSV file that we download from the internet, and put all the file in the folder, and then compile all the CSV file, and open Weka, go to Explorer, and open the file that have been compiled earlier, and then remove all the attribute that did not related to the research. The reason to remove the attribute that did not related to the research is to make sure that the running time of the classifying step did not take a long time to finish the run. So we take only the specific attribute only that will affect to the our research. And then this is the classifying step. The classifying step is to classify the dataset that I have been saved earlier. Open the file and open the classify menu on the top menu. Choose the classifier that need to be test, and then enter the 80% on the split. The 80% is for the training data, and the 20% is for the test data. And then click the start button and wait for the classifying to finish, and take note all the result that we get from the result that we get. So this is the sample result that we get from the classifying step. And then this is the accuracy result that we get from all the machine learning algorithm and all the dataset. So we can see here that we are running all the dataset and machine learning for 3 times for each machine learning algorithm, each dataset. So the reason is to make the result more accurate and have the result that we need. to get the average. So the average is more accurate, and we can see that there is any threshold that we can get. So based on this table, we can say that on the SVM we have the highest accuracy on all the dataset that have been run. So this is the graph, average graph of the accuracy. So we can see here that SVM have the highest result, highest accuracy result than the other machine learning algorithm. So we go to the more detailed result for this dataset. So firstly on board IoT, so we can see here that SVM also have the highest accuracy, recall, precision, and also F-score. So we can determine that SVM is the best machine learning algorithm to use for board IoT. And then this is for each IoT dataset. On here also we can see that SVM also have the highest accuracy, recall, precision, and F-score value. And lastly for the CIC DDoS, also same with the other dataset, we can see that SVM have the highest accuracy, recall, precision, and F-score average value. So this is the parametric result SVM. So we conclude that SVM is the best machine learning algorithm to use to detecting UDP flight attack. So after we compare the accuracy, after we compare the machine learning algorithm, we need also to compare the dataset that we have been tested. So in this graph, we compare the board IoT result, edge IoT result, and CIC DDoS result for the SVM only. So because we only conclude the SVM is the best machine learning algorithm that we said earlier. So on here we can see that edge IoT have the highest F-score value, highest accuracy value, highest recall value, and highest precision value. And beside that, edge IoT also have more consistent value than the other two dataset that we test. So we can say that the best machine learning algorithm to use for detecting UDP flight attack is SVM, support vector machine. And the best dataset to use to train the machine learning algorithm is edge IoT for the real world implementation. So the limitation of the project is this research only focus on the UDP flight attack only, and as we know that there are many type of attack that happen around us, and then the limitation of the dataset, we have only 3 type of dataset only, and 3 type of dataset cannot we cannot sure that there may be another dataset that have highest result than the edge IoT. And lastly is hardware limitation. This is very crucial of this research, and the future work for this research is to improve the number of attack type. So we not only for the UDP flight attack, so we can include the other attack as well. And then lastly, increase the machine learning algorithm type. So not only 5, we can add more machine learning algorithm like K nearest neighbor and so on. So I think that's all from me. So thank you very much for hearing. So thank you, and Assalamualaikum warahmatullahi wabarakatuh.